Today we are going to be discussing energy, potential, and kinetic. And we're also going to try to break last week's stutter counter of 8. Remember, Carol, if we hit 9 stutters, that's a new school record.
That's right, Grant. Kinetic potential energy.
I believe what Bella's looking for is on her boards back here.
Oh, great.
While she tries to find that, why don't I take you guys over to our rural reporter, Cletus Lively, Cherubusco's very own. Yee, Studio 102, welcome! I'm your rural reporter, Cletus Lively, and today we are going to be discussing potential and kinetic energy. Now you might be wondering why there's an absence of my usual farm equipment, but today we're going to a little special place I like to call the Hillbilly Roller Coaster. And we're going to be showing you how this pathetic and kinetic energy works. Alright, so I'm going to take it real slow here so I can really explain it to you. Now as we go up this hill here, our potential energy is rising. And as we reach the top, it's reached its maximum. That means the higher you are, the harder you're going to fall. Now that's potential energy. Kinetic energy is the other one. Basically, kinetic energy is the energy you're outputting. Potential energy is the energy you have stored up. As we go down our hill here, the kinetic energy is rising. And as we hit the bottom just before we stop, it's really hit its maximum. And fun fact, the potential energy at the top of the hill is equal to the kinetic energy at the bottom. Hey, you know, I really appreciate you showing me this. Shoot, I think I done got me another gear. It's just an email. Go ahead and cut it.
Well, it sounds like Cletus may have had some minor road difficulties. Those potholes are crazy, guys. But we're here with a model to help further explain what Lively told you.
Yeah, here we are. As you can see, we have potential energy over here and kinetic energy right here. Potential energy, as Lively was saying, is based off the height and mass of an object. Now you also have gravity in here, which is always going to be based off of Earth's gravity, which is 9.8 meters per second. You also have mass, which is kilograms, and the height, which will be in meters. You can use one of Ms. Kiefer's classic triangle charts here to discover any of the missing variables. With this chart here, you can see that a 10 kilogram object and a 20 kilogram object will fall differently, even though they're the same height, and that further explains potential energy. The heavier you are, the harder you'll fall. Kinetic energy is based off of mass and velocity. More mass less velocity equals more kinetic energy. The equation for kinetic energy is a little bit more complicated than potential. You have to take half times the mass times velocity squared. Half, you're going to want to put that in 0.5 in the calculator. Remember that. Mass, again, is kilograms, and velocity is meters per second. We have one more little chart here to explain that a 10 kilogram object and a 20 kilogram object will move differently because their weights are different. You can also use another one of Ms. Kiefer's classic things here to determine the mass, velocity, and kinetic energy.
And we are now getting word that Cletus is all good and requesting to broadcast again.
Are you sure that's a good idea? I think he might have hit a kid.
Well, yeah, I mean, why would he request it?
Well, I wouldn't worry about it too much. I'm sure they're going to cut that part out, and I don't see you losing your job over this, so just keep recording.
It's rolling, Cletus.
Oh, shoot, we're live already?
Yeah.
Well, here, as you can see, we had a bit of a deer mishap. It is deer season in Indiana, as you know. Got a little bit of damage here. But this is actually giving me a perfect opportunity to take you over to my girl Monica in Studio B, who is a mechanics expert, and is going to explain to you how the energies involved made this damage. Let's go see her. Okay, I think we handled that pretty well. Let's just get out of here before anything works out.
Well, hey there, kids! Today we're going to be chit-chatting about some sciencey things. First topic of the day, the law of conservation of energy. That super lit law states that energy cannot be created or destroyed, only transformed. Kind of like when your husband won't change for your son's bat mitzvah. I mean, you can try to get him to change into nicer clothes, but he still will be the same sneaky cheat that he was the day you got married. And I mean, for some reason, you still blame yourself. All right, let's cut. Cut. Okay, we back up?
It's been live.
Well, all Alrighty then, let's go back to our daily reporters back at the studio.
Well, folks, that's all we have time for today. Thanks for watching.
If you have any story ideas that you'd like to see covered, please keep it to yourselves.
From all of us here at Studio 102, have a great summer, Carol.
Sunny days and friendly smiles.